All right, so I'm looking at 2.5, solve quadratic equations by factoring. We've been talking about factoring, and so now we're going to figure out how we can expand that discussion to actually solve quadratic equations. So before that, we're just going to need to revisit some connections between the different forms of quadratics that we've learned and the graph. So we should all be familiar with this one here. This is called standard form. Right, where you just have x squared minus something x, or plus or minus something x plus or minus a constant at the end. And now we've learned that we can convert that standard form into what's called factored form, right, where we have different factors being multiplied together. So standard form, factored form, and if you might be able to tell, that these two are actually equivalent, right? They're the same function. They're the same function that's graphed over here. If we wanted to prove that, we could think about distributing. We could think about doing multiplying x by both of those, multiplying 1 by both of those, you get x squared. Um, you get x squared minus 3x plus 1x minus 3, which is x squared minus 2x minus 3. So here's standard form, we converted it to factored form, and here's the graph. Let's explore the connections between each of these forms and the graph. So what we learned a while ago is that the axis of symmetry, when you're looking at a quadratic equation, is negative b over 2a. Here our b value would be negative 2. Our a value is what's in front of the x squared. In this case, it's a hidden 1. And so we would do negative 2 divided by 2 times 1. Negative 2 is positive 2 over 2. That gives you 1. And that makes sense that our axis of symmetry would be at x equals 1. Right, so we're just exploring the connections between this standard form equation and its graph. That is all stuff that we've looked at before. But now let's try and find, are there any connections between this factored form equation and its graph over here? And you may not see it right away, but if we look at the zeros, this 0 is at the point negative 1, 0. This 0 is at the point 3, comma 0. And if you notice, x plus 1 matches with the 1 over here. Now the sign is flipped, right? We went from positive 1 to negative 1. But over here, we have x minus 3 and positive 3. They're the same number again, right? 3, 3, 1, 1. But the signs are opposite, right? This is a positive 1. This is a negative 1. This is a positive 3. This is at negative 3. And if we think about why that's the case, well, what happens when x is equal to negative 1? Right? If x is equal to negative 1 and we plug that into our equation here, we're going to have negative 1 plus 1 times negative 1 minus 3. Negative 1 plus 1 is 0, and 0 times anything is going to give us 0. Right? So if one of our factors, if we can factor this into x plus 1 times x minus 3, whenever this x plus 1, whenever this first part is going to be 0, which is going to happen if x is negative 1, because negative 1 plus 1 is 0, then the whole thing is going to be equal to 0, because 0 times anything is 0, and so y is going to be 0. Same thing when x is equal to 3. Right? When x is equal to 3, if we plug 3 in there, we're going to get y is equal to 3 plus 1 times 3 minus 3. 3 plus 1 is 4, but 3 minus 3 is 0. So y is also going to be equal to 0. So what we can see here is the zeros of the function are going to occur when any one of our factors is equal to 0. Right? We can take this standard form, convert it into a set of things being multiplied together. And whenever even one of those is equal to 0, the function will have a 0. And we can use that to solve quadratic equations. We can take advantage of that fact to solve quadratic equations, because if we manipulate an equation to set it equal to 0, then we know, and then if we're able to factor it, we know that the values of x that make any of the factors equal to 0 will then solve the equation. Let's go through an example of how that actually works. So if we start off with something like this, right, 3x squared plus 50x is equal to negative 2x squared plus 55. First thing we want to do is we want to move all of the terms to one side so that the equation is equal to 0, right? Once we have it equal to 0, then we know if any of the factors are 0, then that's a solution to our equation. So how are we going to do that? Well, let's start by combining like terms, right? Adding 2x squared to either side. And that gives us 5x squared plus 50x is equal to 55. And I can subtract 55 from both sides, giving me 5x squared plus 50x is equal to 0, right? 55 minus 55 over here gives me 0. Oh, but sorry, forgot one thing. If we subtract 55 from this side, we also need to subtract 55 from that side, meaning that we just need a minus 55 over there is equal to 0. So now we're going to want to factor our quadratic. We need 5x squared plus 50x minus 55. We first want to start by finding our GCF. In this case, that would be 5. And then we can divide each of the terms by 5 to give us x squared plus 10x minus 11. If you're not sure what's going on at this stage, I recommend you go back to previous videos, specifically 2.4 factoring polynomials, and follow along there. I'm just going to be kind of moving through this kind of quickly because hopefully this is review. So after we've taken out the GCF, we now want to do our magic x, and we want to find two numbers that multiply to negative 11 and add to 10. I'm going to say that we can do negative 1 and positive 11. And that means we can rewrite this x squared minus 1x plus 11x minus 11. And then we can put parentheses around the first two terms, put parentheses around the second two terms, factor out our GCF. We can say x times x minus 1 plus 11 times x minus 1. The GCF of these two terms is x. The GCF of these two terms is 11. We factor the GCF out of each of them. This is what it looks like. And then finally, we can combine what we have outside of the parentheses with leaving what we have on the inside. We can get to this being our factored form, which means our final factored form would be our GCF times each of those. All right. So now if we want to figure out what x is equal to, we want to set each set of parentheses equal to 0 and solve the equation for x. So in the first parentheses, we have x plus 11. Do x plus 11 is equal to 0. In the second parentheses, we have x minus 1. So we do x minus 1 equal to 0. Because if either of these two numbers is 0, when we multiply them, we're going to get back to 0. So x plus 11 will be equal to 0. We subtract 11 on either side when x is equal to negative 11. And x minus 1 will be equal to 0 when x is equal to 1. We can add 1 to both sides. So therefore, our two answers to this quadratic equation, right, to this quadratic equation are x is equal to the set that contains -11 and 1. And finally, you would graph it on Desmos to make sure that your zeros are in fact -11 and 1. You can check that on Desmos, make sure that you got the right answers, but this is how you use factoring to actually solve quadratic equations.